session. Okay, I started recording this one. Okay, I hope you did not go through my Hadoop demonstration video that I shared with you. So I'm just going to go through. Today we are going to cover some of the big data Hadoop demonstration, which means what is big data, what is Hadoop, and why we have to go and use Hadoop, then how Hadoop is going to resolve the big data related issues. Then we are going to see completely what and all topics that we are going to cover out of our discussion in our training. We are going to see very thoroughly. That is the target for our today's session. Actually, I don't want to bore you too much, so I'm going to cover you very less topics. Okay, so you should able to understand what's going on with this big data Hadoop. Okay, so before just go ahead and start our Hadoop demonstration, thank you so much for being here. Thank you attending for my demonstration. It's really great to see you here, because as we know, every day we have to go to office, and being a busy schedule, finding some time and attending and learning extra things is really great. Actually, you already stepped into the learning one, so it's great to see you all here. So let's go ahead and introduce myself in one or two sentences, then we'll jump into our what is big data and Hadoop. Okay, so before we move on, could you please introduce yourself probably in one or two sentences? I think Fanindra said you are from um, some background, but I would like to hear from you all. So go ahead, Fanindra, just one or two sentences from your background, how many years of experience you have, so that I can keep that one in my mind, and I'll try to explain some of the topics.
Yes, sure.
Mm-hmm.
I have total of 4.5 years of experience as a PLSQL developer.
Great, good.
Yeah, I worked on a Unix environment and that's it.
Okay, good, great to hear that. Hi, how about Dilip? Just go ahead and introduce yourself.
Yeah, sure. Actually, I have a total of 5 to 6 years of experience in RIPPL SQL,
Great.
and I'm working in the same company for last 5 to 6 years as
Good,
a PLSQL developer.
good, great. Okay, great. So both are from PLSQL background, which is great. And Jayant, can you able
Uh,
to?
well, uh,
Yeah.
yeah, yeah. I have 3 years of experience
Okay.
in PLSQL development.
Okay, great. Okay, so all are PLSQL. So they, okay.
So, yeah.
Thank you though. Okay, let's go ahead and start. I mean, let me introduce myself. And this is Shiva. I have total 10 plus years of experience, IT experience. Okay, out of that I worked as a Java developer, and quite some time I worked as a mainframe developer. Then from last 4 plus years I am in data analytics. Okay, right now I'm working as a Hadoop architecture actually. Okay, my current role is a project manager for my entire offshore. Okay, and other than this one, I train many people. Not only with this one, I love my teaching. Actually, I love to transfer the knowledge. Even I trained in mainframes, and I trained in Java, a little bit in LR my career. Okay, so in Hadoop alone, from last 2 plus years, okay, I trained more than 3,000 people. Okay, so this includes offline, which is like classroom training experience plus online training experience. Okay, these many people. This batch is going to be my 22nd batch actually. Okay, so I have already successfully completed 21 batches, and I was able to train them people who are like zero from this IT professional. They just completed their masters, and they are just into the market, and they don't know anything about even not PSQ, PLSQL or SQL or Java or C++ or C language. But I was able to train them. I was able to place them in the market with the 5 to 6 years of experience. So as you know, unlike here in United States, we have to have some experience. Okay, so you cannot just go ahead and 1 or 2 years of experience like here. Okay, here we can go with that one and you should able to get the job, but there if you're keeping 1 or 2 years, we are not able. So I was able to train the students where they can go ahead and portray themselves as a 5 years of Hadoop developer experience, or 5 years of probably they can go ahead and portray themselves as a Hive developer or Pig developer. So that's how I would train them. So all you have to do, just try to attend the classes regularly. 1 hour to 15 minutes of class we are going to have every day within this time. Plus just try to have 1 hour of extra efforts every day, and weekends try to again recover everything what we covered entire week. So this training is going to go through for 40 to 45 hours. So just try to, and already like I said, you've already stepped ahead, and you started thinking about learning. So try to put some more efforts so that you'll be there where you want it, because market right now, the current market is training to find out the people who are having the Hadoop knowledge, actually big data Hadoop knowledge. They are like, they're not able to find out. Okay, so if you want to know, like, just go ahead and add this Hadoop and some keywords to your resume if you have already resume in the market, and the next day you're going to see how many calls or emails that you're going to get from different organizations. That is what the requirement currently our organizations are having. So that is the reason people are just learning basics, then little bit advanced one, so then we are able to get the job with a good compensation actually. Okay, so I'm sure I'm going to tell you that in future, after 10 years, people who has the Java knowledge now, people who have started the Java when Java was born, after 2 to 3 years, and how much market they have, how much demand they have in the market, the same way for big data Hadoop guys or whoever is coming in future, they are going to have that much demand in the market. That's what I would like to say for the big data Hadoop guys actually. Okay, so any questions before we move on further? Really, what is big data and Hadoop? I'm going to explain very clearly that.
Shiva,
Mm-hmm.
yeah, what are the prerequisites like to learn Hadoop? Which technologies we should know before we are learning Hadoop?
Yeah,
Like Java is compulsory?
yeah, I'm going to teach that one when we go ahead and introduce one by one ecosystems. You're going to get that one. Okay, what and all we need it. But as of now, I would say you don't require anything. Okay, so but I'm going to tell you why
Okay,
you don't require. So I cannot just say that. I need to prove that one. I'm going to prove that one. Okay.
okay, fine.
Okay, thank you. Any other questions? Okay, great. Let's go ahead and start with our, we are here to discuss big data and Hadoop. Okay, so now many people have started saying that we are going to train you in big data, we are going to train you in big data, we are giving the excellent training in the big data. Then what is big data actually? What is big data? Big data is not a framework, it's actually, okay, it's not a framework, it's not a language actually. Okay, it's not a framework, it's not a language, it's not a technology. What is this one? Currently it's a problem statement actually. What I mean by problem statement, existing systems, whatever we have currently in the market, .NET, Java, mainframes, or probably any ETL related tools, okay, any data or warehousing related tools, and mainly any RDBMS databases, for example, MySQL, okay, and PLSQL, and also DB2 etc. They are straining to process this data actually. It's a big data, means we are getting lot of data. Earlier we used to see bytes, kilobytes, megabytes, gigabytes, right? And also the terabytes. So all the way till this much of data we used to see. That is the reason easily these systems were able to handle the data. But nowadays, as you know, from different data sources, we started getting petabytes of data, exabytes of data, zettabyte of data, and also yottabyte of data. So this data, we started seeing this much of data from different sources. That is the reason existing systems, even MySQL was not able to handle that one, which is like booming from last 15-20 years. With the databases, we are not able to handle that one because the systems are straining to store the data and straining to process the data. They did not expect when they are designing this, when they are developing this product, they did not think like we are going to get this much of data actually. That was the main reason why we are not able to store and process the big data using these existing algorithms. Any questions here? So now you have to understand big data is a problem statement. How many problems that we have? Mainly we are having two issues. One is storage wise. The next thing is processing wise. Clear on this one? Big data is not a framework, it's not a language, it's not a technology, it's a problem statement, which is currently we have that issue with our data. Data is nothing but collection of related information. If you are putting together, that time we will be calling as a data. Big data means it's large in size actually. Okay, it's large in size, it has its own characteristics, and which we are going to see as we go on with our classes. Clear? Any questions here? So you should able to understand end of this one, what is big data, what is Hadoop. End of this demonstration plus introduction class, you should able to understand what is big data and what is Hadoop, right? Are you clear with big data so far?
Yeah, yes, sure. You
Okay,
can proceed.
good. Okay,
Yeah.
so now what and all issues that we have from the storage wise, let me go ahead and introduce or define the big data using 4 V's actually. So what is this V's and all? Okay, volume of data, okay, volume of data, and velocity of data, variety of data, and last veracity of data. Okay, so what I mean by this one, these 4 V's, actually this is the definition that IBM has given for the big data. Volume of data means the amount of data that data source, any data source is generating and getting added to the warehouse. Okay, that is called volume of data. Example, so you can take anything, probably 100 byte, 100 megabytes or 100 bytes or terabyte, 1 terabyte of data, so etc. Okay, this is called the volume of data, the amount of data the data source is generating and we are trying to add to the warehouse. Okay, warehouse or data warehouse, whatever it is, it can, you can take anything, MySQL from amazon.com to MySQL you're trying to add. Amazon.com is going to generate the lot of data, right, every day. So that data we are trying to add from source to destination is called volume of data. Then what is that velocity? So at what speed we are adding the data from data source to warehouse. Okay, so whatever we are adding 1 terabyte of data at what speed, which means weekly. In a week we are trying to add 1 terabyte of data, or in 1 hour itself we are trying to add this much of data, or in 1 month itself we are trying to add this much of data. So this is called at what speed. Okay, at what speed you are trying to add this much of data is called velocity. The variety, as you know, we are having the data in 3 forms. Okay, structured, semi-structured, okay, semi-structured and unstructured. So what I mean by this one here is structured is nothing but wherever you are seeing some structure to your data, where you can just go ahead and read out, okay, this is what this column is going to be, okay, this related to your telephone number, the next thing is call history, and next thing is your location. So you are able to just specify, or you are able to see some structure on top of the data, that is called your structured data. The basic example for this one is whenever you are going to store the data in the RDBMS related database, we are going to call that one as a structured data. Okay, the semi-structured, where you have or you're given only off meaning to your data, which means like XML and JSON, or probably your clickstream data. Nowadays it's a semi-structured, which means only off way only you can say this is a structured data. Remaining off way is like you have to process them to that half of the portion to make it as a structured one. That is a semi-structured. The last one is unstructured. So what I mean by unstructured here, it does not have any rows and columns here. Okay, it's just a plain old text files or audio files or video files. Then we are going to call that one as a unstructured data. Okay, so this is called variety of data. Then the last one is veracity. Okay, what I mean by this veracity here is whenever you are trying to add the data probably from ABC source, probably if you take the example of bank, okay, bank is going to generate lot of data in a day, probably around, if you take overall the bank data and all, 10 terabytes of data that you are going to see from each and every day. So out of this 10 terabytes of data, what data or what amount of data is valid for you to proceed with data analytics is called big data. It's called veracity. So you are trying to extract what is the valid data. Probably remaining data is valid data for you, but as of now, currently, whatever data analytics that you wanted to do, you have to extract the valid data out of this one. That is called veracity of data. So now going back to our big data definition, if your data set is having these four characteristics: high in volume of data, high in velocity, high in variety, high in veracity, which means your data is having this is the characteristics, then we can call this one as a big data. Clear about the big data definition using four, which is very important for your interview as well as the certification purpose. Okay, volume, velocity, variety, veracity. Good. Okay, so from where we are getting this much of data? Probably we are talking about this much of data. So just let me go ahead and show you one small this thing here, and you can see that. You can see here this picture clearly shows within a 60 seconds of time how much data that we are adding from the different data sources. Okay, YouTube, how many videos are getting added to the warehouse, and how many new domains are getting registered, how many images are added to the Flickr, how many voice calls are happening over the Skype within 60 seconds, 1 minute of time. So this clearly talks about volume of data, variety of data, velocity of data, and also veracity of data. Okay, so that is all about the big data definition from the IBM side. Okay, so this is a statistics. If you want just to go in and see that in the goglobe.com, they've clearly mentioned from the different data sources how much data that we are seeing every day, every 60 seconds, which means within 1 minute of time. Okay, so that is called big data. Then how we are going to address these big data related issues? Okay, so now, as you know, the data that you are getting from the different data sources here, probably this is my MySQL database, and your MySQL database, you are trying to add some data, probably your YouTube or your Facebook or whatever it is, you are trying to add the data into this one. So this database is going to handle probably terabytes of data, millions of records, not billions. When you are going to store the data in, not in a terabytes, in a petabytes of data, your single server or your single machine is not going to handle that much of data. You know that one. You are already in this market, you know this one. So in order to handle this much of data, how you have to do? Again, you have to route your data to the different machine, different database, and you have to store that one data. So then again, one more. So as you know, you're getting this much of data every day, then you have to route to the different machines to store the data. You keep on adding the systems to this one. So how many systems that you can add? Only limited systems. And after that, what you have to do? You have to start deleting the data from the existing, whichever you don't require in the existing, systems or databases, you have to just start purging the data. We'll be calling this one as a purging, deleting. You're not going to retain the data. But as you know, when you're not going to retain the history of your data, probably 10 years, 15 years back data, you are going to see a lot many issues in future. You may not able to take the exact business decisions because you don't have the raw data. What happened 5 years back when you have introduced ABC product, you don't know the statistics. You don't know what happened to your company. So you may not able to introduce the product on time with the confident actually, or you may not able to address the customer complaints 100%, or you may not able to stop the your organization from the huge loss because of so and so thing is going to happen. That is the reason we are going to see based on the past data that is available with you. So these are all the examples where you have to retain your data, big data, for your future purpose. So using these existing techniques, whatever Java, .NET, MySQL and all, the systems are training to retain the data. The more data that you retain, the more training is going to happen, the more time that you are going to take to process the data. So as you know, for example, you kept on adding the systems something like this one, but in future this is the 4 years of data, for example. So I would like to find out something, some statistics out of last 4 years of, from last 4 years. Then how we have to do, you have to keep the data again together. You have to process. In order to process the data, you have to put all data together. You cannot go ahead and process individually in this one, in this one, in this one. There is no mechanism as such. So whenever you are going to keep this entire data together, then your processing related issues will arrive. Okay, the storage wise issue, this is the issue. The processing wise issue, existing one is that this is the issue. So that is the reason we are not able to address the processing wise issue also using these existing computational techniques. This is what exactly that we have, the big data related issues from the existing computational techniques. Clear? Clear, Funny, Dilip and Jayant? You should able to understand what is the issue that currently you have out of your PLSQL, or not only with that, any database, any warehouse system, or any technology that we have in our market. Any questions? You can go ahead and talk to me. Any questions?
So the data is not normalized data.
Yes, we are getting a lot of unstructured data. Okay, so earlier we used to get lot of structured data. That is the reason we are able to manage that one. We are able to manage, but nowadays the machines, the devices, the different data sources that we have currently in the market, it is generating lot of unstructured data. Because of that, we are not able to store, we are not able to process the data. Your systems are training to process the unstructured data actually. It means you have to put lot many instructions to process the unstructured data. That's all. Okay, so now in order to address this one, they came up with, there are many technologies where they can address this one, but they are failing at certain positions. Okay, in order to, probably they are failing in order to just probably at the storage point of time, in order to just to process that one, they are failing. So in order to address them, okay, in order to address and going on top, we have seen Hadoop. Hadoop is what? It is a, let me go ahead and define the Hadoop. Hadoop is a open source framework. Okay, so let me go ahead and define what is Hadoop. Hadoop is a open source, I'm telling again, open source framework. Okay, I use two words here, very, very important thing. Open source means free to use software. Framework is 70 to 80% of work will be done by the framework, and developer has to take care of what remaining 20 to 25% of the work. So it's a open source framework written in Java. You don't have to know anything Java. Okay, so if you want to go ahead with something written in Java on Linux platform, okay, completely on Linux platform, okay, which is intended to resolve the big data related issues in terms of storage and in terms of processing wise related issues. Big data related issues in terms of storage wise, in terms of processing wise. This is the called Hadoop. Okay, So why we have to use Hadoop when we have Hadoop kind of technologies in the market here is Hadoop is having lot many features actually. Okay, it's a scalable. What I mean by scalable language here. So Hadoop is going to work with the master slave architecture. Okay, so I'm just introducing slowly about Hadoop just to concentrate here. What is Hadoop? We have discussed. We are having many definitions for that one. I'm going to teach you one by one as we go on with our classes. Then what is how this Hadoop is going to work out? Hadoop is going to work with the master slave architecture. Okay, what is this master slave architecture? I'm going to teach you very thoroughly. So now, for example, going back to our legacy systems, this is your database, right? This is your database, and you are getting some data from the data source, probably Amazon.com. Then how you are going to store the data? You're going to store the data in single machine. This is a machine. Database is a machine actually. You have to design and you have to install that one and you have to keep that one as a database. Okay. So now I'm getting the data. So I'm going to store in MySQL. Okay, so now maximum how much data it can handle. Just think like you're just using super duper computer. Probably I'm going to get the 10 terabytes of data from my Amazon.com and I've stored in that data into this one. As you know, in order to process this one 10 terabytes of data, this single machine has to work on top of this one. If you're writing any program or any logic, any SQL queries, so which one has to process? Only single machine maximum, whatever the techniques that we are using from the MySQL or anything, single machine has to process these queries actually. Your set of scripts, whatever you wrote on top of this 10 terabytes of data. Okay, so now let's go ahead and see how your Hadoop is going to process this 10 terabytes of data. So like I said, my Hadoop is going to work with the master slave architecture, which means master is going to take care some of the slaves here. Okay, so something like you can think like this is a master, this is a computer. Just think like this is a computer, this is a master computer, and these are the slave computers. Slave computer 1, slave computer 2, slave computer 3, something like that, slave computers. So what I did, I put 10 computers under my master computer, and master computer is the one who is going to take care of my all my slave computers. It's going to assign the work and it's going to see what is happening with that. So these guys has to report back to this one. So now these 10 computers with one computer, they can talk each other. These are master computer, which is at the top level where it can assign any work to my slave computer. So now this is just think like this is a computer, one computer and this one. So this, if you're putting more than one computer together within the network, that time we are calling that one as a cluster actually. What is cluster? If you're going to put more than one computer within the network where they can talk each other, okay, that is called cluster. So this is called cluster actually. What is cluster? If you're putting more than one machine together within the cluster, machine in the sense computer, if you are going to put more than one computer together within the network, that is called cluster, where they can talk each other. Cluster is not unique for your Hadoop. It was already there in the market, but our cluster is going to follow the master slave architecture model actually. So what I mean you can have one cluster something like this one where they cannot talk, they can talk each other, but there is no master slave architecture. So where this is how you are designed your cluster. This is also one cluster, okay, but this is the master slave architecture cluster. Okay, so that is the difference that you have to understand. Let me go let it back. Okay, so now here you can see 10 machines that I have under one machine, master machine. So let me go ahead and again to store this 10 terabytes of data, what my Hadoop framework is going to do here. Okay, this is my 10 terabytes of data. My Hadoop methodology says that instead of going and storing in one machine, it's going to ask me to divide into 10 pieces. Why you have to go with the 10 pieces and all, I'm going to tell you very clearly. 1, 2, 3, 4, 5, 6, 7, probably 8, 9, 10, whatever. So 10 pieces we have divided into 10 pieces. 10 chunks of data. We'll be calling this one as a chunks of data, pieces of data, or some other things which we are going to see that one very thorough. 10 pieces that we have divided. So each piece is going to be have how much? 1 terabyte of data. So that is how my master machine is the one who is going to send each terabyte of data to the single machine. Only 1 terabyte of data, 1 terabyte of set. So can you see now here, instead of storing in a single machine, I have stored in a 10 different machines. So this is how we are going to distribute the data into multiple computers. Are you clear with this one? How we resolved, how we just address the storage issue using your master slave architecture. You are going to divide the data and store the data, and you are not going to store your entire 10 terabytes of data. Even though this machine is enough capable to handle the 10 terabytes of data, my Hadoop methodology is going to say that you should not store in a single machine. You have to divide the data into chunks of data, and each slice, each chunk should go into the different machine. Actually, that is what my Hadoop methodology says here. So that's how I store the data. Computer 1, computer 2, computer 3, something like that, 10 computers. Can you see now here? So this entire part, how did we distribute the data into more than one computer? We are going to call this one as a, from our Hadoop side, HDFS, Hadoop Distributed File System. Hadoop Distributed File System. This is called. Using this one only, we address the storage issue. How? Means whenever you want more machines that you want to add, simply you can go ahead and add to the cluster. It is a scalable language, which means you can add how many machines that you want. You can just simply go ahead and add to the cluster. That's all. The more storage you want, just go ahead and add one more machine extra to this one. So this is also part of your, again, your HDFS file system. Okay, so this is called HDFS. Are you clear with this one? Are you clear, or did you understand how we are going to address the storage wise issue using your Hadoop?
Yes, Shiva. What is the role of master computer?
Yes.
Just it process the data. It is where it's coming from, like Amazon sites to this source.
Yes, excellent question.
Computer.
Excellent. So your master computer role here is, it is going to find out the data for where it is. So whenever you are going to store the data, anything into your Hadoop cluster, that request will go to the master computer. Master computer is the one who is going to check what is your file size, and it's going to divide into based on some method, some architecture, which we are going to say as we go on with our classes. It is going to, based on some parameter property, it's going to divide this file into chunks of data, and it's going to route that each chunk into the different machine, because master computer is the one who knows how much this each slave node has loaded, how much work is there, how much space is left over, and how much work is there currently your each slave computer is having. So that is the one who is going to control by who? Your master computer. That is the reason master computer is the one who is going to do almost everything other than the actual data storage here. So did we store any data here? No. Entire thing is routed to the slave computers only. So that is the reason master is the one who is going to be the first point of contact for your clients, is going to be the your master computer. Master computer is the one who is going to decide how we have to divide the data into chunks of data, and each chunk has to go into the which machine. Okay, that is what it is going to be decided by your master machine, master computer.
One more question.
Mm-hmm.
Yeah, can we install another master computer? Like, is it?
Yeah, we'll be having more than one master computer within the one cluster, and but the roles and responsibilities are going to be the unique. Okay, so this master computer is going to take care of some responsibilities, and this master computer is going to take care of some responsibilities. Yes, but we are going to divide the. Go ahead.
Okay. Yeah, both are interrelated, but master computers.
Yes, they can talk each other, but the one which is taking a, probably if it is taking ABC responsibilities, and this master computer does not have to take the same responsibility, it is going to take some other responsibility. Exactly, that is what we will be having more than one master computer within the cluster, where it's going to take care of its responsibilities, unique responsibilities.
Yeah. Okay, fine.
Good. So now the processing wise, as you know, you have wrote the script or SQL or whatever it is, and you are going to process on top of this 10 terabytes of data, and your single machine has to process this entire data. Then it will take obviously lot of time. You wanted to see your results within a day, but because of this system is having 10 terabytes of data, huge data, you are not able to process on time. That is exactly it's happening with our existing systems. But whereas the 10 terabytes of data I've distributed the 10 machines. So now the logic came here. This logic is going to work how? Let's go ahead and see here. The same logic we are going to write to process the same data. Data is same, right? The data format, the data that we have stored here and here is going to be the same thing. Then how we are going to process the data? We are going to process using our Hadoop methodology. This whatever logic that you wrote, that will be again sent to the master computer. Master computer is the one who knows where did I distributed this data, where did I divided and distributed this data. That is what it knows. That is what it's going to maintain that records actually. So now this machine is the one who is going to send the same logic to the different machines here. Okay, so now this logic is sent to the machine 1, and the same thing machine 2, same thing machine 3, something like that. 10 machines we have sent to the same logic to the 10 different machines. So now instead of putting the data together and processing, what my Hadoop methodology says here is this logic is going to work on top of this slice of data only. This logic is going to work on top of this data only. This logic is going to work only top of this data. The logic is same. The data is only small portion of data. So 10 terabytes of data is divided into probably small terabytes of data, that each terabyte of data, only 1 terabyte of data only, this machine has to work only on 1 terabyte of, obviously it will take less time. So once you do that one, the results will send back to the master machine. Master computer is the one who is going to consolidate your final results and send the results back to the client actually. So here you can see, instead of working only with one machine, you are making sure that 10 or 11 machines are working for you in this methodology. So this is called exactly the parallel processing. Okay, instead of one machine, one computer is working for you, you're making sure that 11 computers are going to work for you. This is what exactly the master slave architecture. This is what exactly the parallel processing. So the more power that you want, you can just go ahead and add the more machines to your cluster actually. So right now our Yahoo is having 45,000 machines together. How many? 45,000 machines. Hadoop cluster size is going to have how much? 45,000 machines. With that only they are able to do their operations right now. Clear? The way we processed here, you can see, instead of moving the data to one computer, we are just going to process the data how you divided, you are going to process in the same way. That technique is called map reduce. Map reduce is a programming techniques using which you can process the divided data, and you can process the individually from the different machines with the help of your HDFS file system. So using this MR only, we are going to process the, or we are going to address the processing wise related issues. Using your HDFS, you are going to address the storage wise issues. These two core components was the kind of native sources for your Hadoop actually. With these two concepts only, our Hadoop was born back in 2006 actually. Okay, when they started working on this one in 2000, back in 2006, they were born. But on top of that, we got many ecosystems which we are going to see very thoroughly. Clear on this one? HDFS, map reduce. The storage wise issue we have addressed using a distributing your file into more than one computer, and processing is also you are sending the logic where your data resides so that it is going to work on top of your data on chunk of data only, the small portion of data only.
Well, sure. This map reduce is an written in Java code, right?
Exactly. I'm going to
Where?
I'm
Yeah.
going
Where
to
we write this one in master computer or in slave?
we are going to write in a separate file. That file will be sent to the master. We are going to see that architecture very thoroughly.
Okay.
We are going to just write in one file. That file will be sent to the master computer. This entire thing, we are not going to write any logic to go ahead and okay, slice of data has to go here and store here, and the portion of data, whatever logic that you wrote, and it has to be processed by this machine. We are not going to write all those things actually. However, how you used to write the logic for your single machine, exactly the same way you have to write. Just think like you have only 10 bytes of data or probably 100 bytes of data. You can write the logic for that one. It's going to work 10 terabytes of data also. Your framework is going to take care of that one completely. All you have to write as per your small data or big data, whatever it is, you have to write the logic. That's all. The rest of the things are taken care by your framework only. Okay, so now we have seen the HDFS and MapReduce. MapReduce is a programming techniques. Okay, without just with MapReduce we cannot go and do your processing component. So what we have to do, we have to know basic, very basic. I'm not talking about advanced, very basic core Java knowledge, or C++ or Ruby on Rails, okay, or Python, etc. Some of the programming techniques where you have to know to start with your MapReduce program. So as you know, people who are having the basic core Java knowledge, where you have to just know about the file handling and probably just manipulating the data and all, you have to know that much, not more than that one. Okay, so maximum you have to know file handling, collections. Okay, these are the two small topics which you can complete very if you have some basic programming language, but it's okay. So you decided you don't want to go with MapReduce program, you don't want to learn any Java or any C++, any Python, then if no Java, that is how people have already started struggling. People are having the Java knowledge in the market are very less. So now that is how they started. If you know the SQL, E0 SQL knowledge, you can go ahead and portray yourself as a Hive developer. Hive is same as SQL. There is no difference at all. Hive is going to work same as SQL. So those queries, the E0 queries, whatever you wrote in Hive, those queries will be converted actually into series of MR, MapReduce program, by Hive framework. Okay, so here you have to understand here, my MapReduce program is going to work end of the day using your Hive, but you are not going to write any single Java code. All you are going to write, you are going to write your problem statements, or you're going to write your business requirement in terms of SQL. Those queries will be converted into series of MapReduce program by who? Hive framework in the background. We are not going to do it all. So if you want to portray yourself as a Hive developer, you don't have to know single Java line also. Okay, so that's what I was telling you. To learn your Hadoop, you don't have to know about Java. Java is not a prerequisite for that one. But as you know, we are going to cover 100% this one. So you can try something out of this one, and people who are going to talk about MapReduce in future, when you join as a Hive developer, you're going to know that okay, this is what is exactly the MapReduce one. You don't have to know about coding and all, but you should know about the process, then you will understand very easily. Knowing the process is very simple. That's what I'm going to teach you throughout my training. So all you have to just concentrate and get it that, and out of my all topics you have to select one among them, and you have to just proficient, or you should be like well enough to answer in an interview. That's all. You are not expected to learn each and everything that we are going to discuss here. No. So now, if you don't want to know, or you don't know about SQL, then we have one more option that is called Pig. Pig is going to work, is a Pig scripting language. It's not a SQL type. It's going to use its own language, Pig scripting Latin scripting language, but it's very easy. It's not a web scripting or Java scripting or other scripting and all. It's going to be very easy. It's kind of English kind of thing. When you read that script, you will understand like, okay, this guy is trying to do something out of this script. Okay, that's what you're going to see. Very easy to learn. Okay, and these transformations, we'll be calling this one as a transformations, will be converted into series of the same thing, series of MR by pig framework. Okay, you can go ahead and portrait. You don't have to learn anything about Java. Okay, the next thing is HBase. HBase is the NoSQL. We are going to see all these things. NoSQL database. Okay, so it's a columnar database. Okay, columnar DB, where you can store billions of records, not million, billions of records. Okay, not only SQL. NoSQL means not only SQL. We are going to see very thoroughly how this architecture is going to work out. Okay, it's very, very important thing. I'm going to teach you from all the way basics to till advanced level. I'm going to give you the use cases also on top of this one. So that is called NoSQL database, is called HBase. And also we are going to discuss very thoroughly Scoop. Okay, Scoop is the ETL tool where if you want to import the data, probably your organization is using MySQL from last 10-15 years. I wanted to import the RDBMS database, RDBMS data from different data source. We are going to use Scoop actually. Okay, we are going to import the RDBMS databases data into Hadoop. Okay, and once you put the data into Hadoop, you can go ahead and apply the MapReduce, Hive or Pig or HBase. These are all your processing components. Okay, and these are your storage component. And using your Scoop, you can just dump the data. You can import the data from, probably for the same example here, you have already 10 terabytes of data. Using this one, you're not able to process the data. Then what you have to do, you have to use the Scoop tool. Is very, very small but very powerful. You're going to dump the data and you're going to put it here. So once you put the data here, you know that one what to do. You can apply MapReduce or Hive or Pig. Generally you'll go ahead and apply the Hive only, because you're going to, is same as Hive is going to have the same as SQL. So whatever queries that you have to apply, you can apply the same thing here also. Okay, hi Shravan, we started, we almost end point, but just let me know and we can talk later, and how we are going to see this one. Okay, so just to stop here, after this class I'm going to talk to you. Okay, so now let's go ahead and see what else we are going to discuss. We are going to discuss about Flume. Flume is again ETL tool, using which we are going to import the streaming data. Okay, we are going to see the streaming data. Okay, that is what we are going to import the streaming data from different data sources, probably your access log data, your server data, mail server data, Apache server data, or probably your Tomcat server data, or probably your airplane data, probably your satellite data. You're going to get the streaming data, which means continuously one data source is generating the data. That's what you're going to collect and put that data. And also we are going to discuss Uzi. Uzi is the scheduler actually. What I mean by scheduler, in order to run these particular jobs in a particular pattern actually. So as you know, you cannot just go ahead and use the MapReduce or Hive always for your data analytics actually. Your organization is going to choose all these things in order to perform the data analytics. It's not just like that. You cannot go ahead and use one developer and you cannot just go ahead and do your data analytics. You have to use more than one thing and to address this one. So scheduler is the one. Uzi is the scheduler using which we can apply. You can run your jobs in a particular desired pattern actually. We are going to see very thoroughly. On top of this one, we are going to cover, and I'm going to give you the software which can be accessed by 24/7 lifetime. Okay, and also we are going to see the admin related course from 30%, almost 30% of admin related course that we are going to cover. Let's go ahead and tell you that one. So this admin related course is going to be installation of single node cluster. Okay, installation of multi-node cluster we are going to see. What I mean by multi-node cluster, more than one computer, how I'm going to connect together, and how I'm going to make this one as a master computer, and how I'm going to make this one as a slave computer, how this data will be divided, and all those settings are configuration related things related to your admin side, we are going to see very thoroughly. Okay, and also we are going to see important configuration related things. Okay, we are going to see very thoroughly, and also I'm going to teach you very important configuration settings within our admin, guys, and also all ecosystems installation. Ecosystem in the sense Pig, Hive, HBase, Flume, Uzi, all these things we are going to see very thoroughly. Okay, we are going to discuss very thoroughly installation part, all this one. Okay, on top of this one, we are going to see the advanced data analytics also in my training. Actually advanced in the sense Spark. Advanced data analytics is going to be the Spark is the one which is just right now it's started slowly taking the market capture with the help of your Hadoop. So you have to know about Hadoop in order to start with your Spark, actually, to make sure you are the Spark developer actually. So I'm going to cover Spark core, okay, Spark streaming. Okay, we are going to see very thoroughly, and also the Scala. Scala is a functional programming language, okay, using which you can just go ahead and develop the Spark application. So as you know, MapReduce cannot do anything without your Java and all. The same thing, this Spark cannot do anything without your Scala or Python or anything. So now we are going to see very thoroughly about Scala, and it's very simple, very powerful, and it's very easy to learn, and you are going to love it if you are just new to your Scala, and you are going to love it actually. It's very easy, and you are going to enjoy a lot with Scala actually. So okay, we are going to see that one very thoroughly. Okay, functional programming language, and also the installation of Spark, Scala, and different cluster managers. Okay, we are going to see standalone. I'm going to teach you very thoroughly on this one. I cannot cover each and everything in one class actually, so I'm just going to go through a high level one. So if you have any questions, stop me. Spark on Yarn, Spark on Mesos. So these are separate courses actually, but I'm going to cover for you completely. Okay, and integration between Hadoop and Spark also we are going to see. We are going to collect the data, streaming data from different sources. As we collect, and we are going to process the data also, we are going to see very thoroughly. So on top of this one, we are going to cover the business intelligence to report tool also. Okay, the first thing is we are going to cover Tableau. Okay, installing Tableau. Tableau is the business intelligent BI tool using which you can create the report visually, and you are going to see how to connect different data sources. Also I'm going to teach you, and creating sheets, okay, dashboards, and also stories. Okay, I'm going to teach you very thoroughly on this one. Okay, on top of this one, you're going to get the support on resume preparation. Okay, and interview questions. Okay, and also project guidance, and certification help. Okay, so these are the things that we are going to see very completely, and also here integration with Hadoop we are going to see very thoroughly here. Okay, these are the topics that we are going to cover very thoroughly here, and also the material that I'm going to provide you to help out the certification also, and it's going to cover the vast subject in our things. And if you want, I can share this complete course content also with you. So any questions from the beginning?
Hi Shiva, Jayant.
Yes, Jayant.
Yeah, small doubt. When this Hadoop will come into the picture, like to load or to process the data, like in data warehousing techniques or like uh, the data processing
Data,
from the client side.
yes.
For example,
Uh-huh.
for example, in my Yahoo Mail account, the 10 years back I have an attachment. For example,
Uh-huh.
okay, I'm going to pull that pull that attachment.
Uh-huh.
So here, Hadoop will come into the picture, or like getting the data from the Yahoo servers. So
Exactly.
it's a very old data, right?
Exactly, your old data, but your Yahoo might have organized his data or their data into multiple computers. So instead of pulling the data from the single machine, they might have distributed that 15 GB of data or whatever data they might have distributed into multiple computers. They pulled. The way they are going to process in the background is going to be this way only.
Okay. So and for data warehousing techniques, also we use this Hadoop system, right? For
Excellent.
loading the local
Yeah.
data.
Yes, we are going to use that one.
Okay. Yeah, that's it.
Yeah, Shiva, I have a question.
Go ahead, Funny. Go ahead, Funny. I can hear you. Funny, can you hear me? Oh.
Any limits for these modules?
I'm sorry, Funny. I was not able to hear your question 100%. Could you repeat one more time?
Yeah, why they have introduced these many modules, big, hive, HBase, as they're doing the same work, right?
Yes, excellent question. So as you know, people who are having the only because of the skill set actually, because they developed a lot many MapReduce programs to maintain them itself, they are putting a lot of efforts. So that is the reason they came up with these components, mainly these two, pig and hive. Okay, pig and
Okay.
hive is going to work same as your MapReduce only, but as a pig developer, as a hive developer, you don't have to write this many big lengthy programs and you have to maintain them. In future, all you have to maintain 5 6 queries, and those queries will be like converted into series of MapReduce program from your framework. Okay, so you don't have to maintain explicitly that one. And HBase is a columnar database which is not going to use your MapReduce program. It is only designed to deal with your large amount of data, billions of instructions, but you are going to see the fraction of seconds your response. So okay, that is different one. And Scoop is the one who want to like import or export the data back and forth from Hadoop to RDBMS. That is different. And Flume is the one who is going to collect the data from streaming data. It has its own unique responsibilities all the way till this one. Okay, and these three are common. This is only purely because of the knowledge people are going to have Java, C++, Ruby on Rails. That is the reason they introduced these two. Right, Funny?
Oh, yes, Shiva.
Okay,
Got it.
good. Any questions, Dilip?
If we want to learn like Hadoop, we must know any one of these MapReduce or Hive or
Excellent.
are
Or
going
you
we
can
need
go
to
ahead
know.
and go ahead and as a H-based developer, Scoop developer, or Flume, whatever you want. It's not does not mean that you are to only in the processing components. And who's going to do the related H-base? Who's going to do the Scoop part?
Okay. Okay.
Okay, you have to know basics little bit about what is MapReduce, what is Pig, what is Hive, but you have to select one among these things and you have to be very proficient in that.
Okay. Okay. Fine.
Okay,
Okay. Is there any other technologies which can process the big data? Only Hadoop or
we have some other things, Cassandra, MongoDB and all, but they are only related to your databases related things. As of now, the parallel processing, there are many things, but HANA is there, and one more thing is that, but they are not really up to, they did not meet what we are doing with our Hadoop with the big data actually.
okay, they are also have the same like a HDFS architecture.
No, 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 that is completely different.
Okay.
Good. Any other questions? Okay, then if you don't have any questions, we can wind up today's class, and tomorrow we are going to meet again at 6 a.m. Okay, I'm going to talk to you offline. Okay, thank you so much for your time, and talk to you soon again.
Yeah.
Yeah,
Thank you.
thanks, Shiva.
Thank you, Shiva.
Thank you. Thank you. Bye.
Bye.